Assalamu alaikum. In this lecture video, I'll try to cover the evaluation of structural models. In the previous video, I talked about the measurement model, right? So after completing the measurement model or after finishing the measurement model, you need to investigate the structural model, right? So there are some steps. By the way, in this video, first we will learn some steps or basic or some theories of evaluation of structural model, right? And then we'll do a practice using smart PLS 4, right? Okay. So some key steps actually. In the structural model, first of all, you need to check the collinearity, right? And then you need to check the path coefficient, then the coefficient of determination, I mean R square value. Next, we need to investigate the effect size, which is F square, and then the predictive relevance, which is Q square, and finally we'll test the hypothesis, right? So there are 6 key steps of evaluation of structural model, right? So first of all, what is collinearity? Collinearity is basically used variance inflation factor to check the multicollinearity, right? So I talked about the multicollinearity or collinearity in the previous video, right? So uh, for quick reference, if the VI value is greater than 5, it's indicating the high multicollinearity, right? So we need to, before build the model or before test the hypothesis, we need to ensure the independent variables are not highly correlated, right? So if the independent variables are highly correlated, the model will be misinterpreted, right? Okay, so next one is path coefficient. What is path coefficient? Path coefficient shows the strength and direction of relationship between the construct. Very simple. We calculated the regression analysis, right? So when we use the single, I mean, when we have only two variables, so we can investigate the path coefficient using the beta value, I mean, the strengthness of beta value, right? But here, there are lots of variables, I mean, the independent variables, and we need to investigate the strength and direction of relationship between the construct or among the construct. So using the path coefficient, we can do it. Use bootstrapping to test significant level, right? Okay. Uh, the value of the path coefficient between approximately the -1 to +1, right? And we will consider the t statistics and p value to test or evaluate the hypothesis. Okay. Coefficient of determination is basically expressed by the R square. R square measures the model's explanatory power. Okay. Uh, R square value is basically from 0 to 1. So when the value is close to 0, it means the explanatory power is quite low, but higher values, I mean close to 1, indicating the better explanatory ability, right? So what is the threshold value? Commonly used if the value is from 0 to 25, I mean 0.25, it's very weak explanatory power, right? On the other hand, up to zero point 0.5, I mean 50% is the threshold value. It's moderately explanatory power. And when we have the value greater than 0.75, it says that substantial explanatory power. But to be honest, very close to 1, it should be, it's indicating very better explanatory ability. Okay, the effect size, it's expressed or denoted by the F square. The effect size evaluates the impact of independent variable on the dependent variable. Once again, impact of independent variable on the dependent variable, right? Okay, what is the threshold values? So F square 2%, it means very small effect. Up to 15%, it's medium effect. When it cross the 35%, it's a large effect. I mean, independent variable will have the large impact on the dependent variable, right? It helps determine the practical importance of construct. Okay. And finally, the predictive relevance. So it is expressed by the sign Q square. Q square is assessed using the blind folding procedure. So in the smart PLS, you will find a option blind folding. So using that option, actually we can calculate or investigate the predictive relevance, right? The predictive relevance indicate the model's predictive accuracy or predictive relevance. Actually, to be honest, in many cases we stopped with the value of r square, but how r square value is, how much relevant the r square value, it is expressed by the q square, right? So q square is greater than 0 is fine. I mean, positive q square value suggests the predictive relevance, while negative values indicate a lack of relevance. It means if the q square value is greater than 0, it's fine for your model, right? Okay, so right now it's time to hypothesis testing, but it's blank, right? So before go to the hypothesis testing, actually we will practice a uh, we'll practice in the Smart PLS 4, right? Using a dummy data set. Okay. We actually took this model from this paper, right? Social media use have will have a impact on internet addiction, and internet addiction will have an impact on subjective well-being by employee well-being, and social media use directly have the impact on or effect on the subjective well-being. On the other hand, digital skill, it's a moderator variable, right? I took this model from this paper, but actually, to be honest, I don't have the data set, but I take this model, right? So there is a big question, where is data set? So using the computer simulated data, right? Using a simulation, I created a data, or is right? Uh, okay, run as administrator, yes. Okay, just wait for a minute or very few times. Smart PLS 4 is opening, right? Okay, that's great. So first of all, I need to create a new project, because in the last project, actually measurement model practice, we took a very critical model, actually, right? Critical conceptual model. That is why in this tutorial, actually, I'm using a very simple model, right? Okay, it's taking quite some time. Okay, just create a new project. Structure is structural model practice, right? So it's a model, a new project, import the data. This is the structural model practice, the computer generated simulated data, actually, basically, right? So just import here, all the data's descriptive statistics are in here, right? So go back to here and create a model. So what is the model? I need to create a model. For example, sorry, I need to choose a model. PLS SEM. Here is structural model practice. Okay, so save. Now this is the workspace. Okay, so I need to create a model. For example, social media use. This is one. The social media use. Okay, I'm making it sorry, left side. Okay, done. And then another one is, what is the model? Internet addiction. So internet addiction have 6 values, right? So internet addiction, for example, I'm making it internet addiction. Okay, and finally the employees well-being or subjective well-beings, is, think about this, to be honest, is not the uh, real data. That is why Okay. So second one we learned, uh, need to connect it. So direct relationship, direct relationship, right? And this is the mediating variable actually. So just make it here and okay. So this is a model, right? So using this model, we have already created a model. So go back to the here, go back to the here steps. So first of all, need to polarity test and then path coefficient polarity test. How will test? Select smart PLS, start running. Okay, here you will find the polarity test, multipolarity. What is that? See here. So all the VI values are quite fine, right? Less than 5, right? Uh, though I believe less than 3 or up to 3 is fine, but theoretically it's fine. 4.69, it doesn't matter. Okay. So so we test the polarity. It's fine, right? Okay. So next one is path coefficient. So how we can investigate the path coefficient, calculate and bootstrapping method. Okay. So here is the 5,000 subsamples using the bootstrapping method. Just start calculation. Okay. So this is the bootstrapping method, right? So here we need to test the path coefficient. Okay, this is the path coefficient, right? So here you will see the path coefficient, the original sample size. This negative relationship here is the strongly positive relationship, and here is moderate relationship, right? Okay, and what is the significant level? And okay, need to investigate the coefficient of determinant. It means we need to investigate the R square value. Okay, so here you will not find the R square. Oh, sorry, you will find the R square values in here. Uh, absence. Okay, so in that case, actually, I need to go to here, smart PLS here. Please see here the R square value, right? So R square value in this model is 56% and 40%, right? So if we go here, so 59% variability, right? And it's the 40% of variability R square. This is the R square value. Okay. So we can calculate the R square value in this way. And third one, sorry, this is the third one. The fourth one, we need to test the effect size, right? How is effect size? Just yes. Oh, okay, calculate smart PLS, start calculation. What is the effect size? F square value. Here, the effect size is too high, right? Please see here, the effect size is too high. Okay, it's only 0.008. It's a very low effect, right? And social media uses have very large effect on employees' well-being and internet addiction. My God, it's too strong effect. Okay, so last one, predictive relevance. So how we can calculate the predictive relevance? Just go back, calculate, go to the blindfolding. Okay, click here, and you will see the predictive relevance, class integrated constant. See the predictive relevance Q square. So I told you, as this is the independent variable, right? So predictive relevance, this one, 22% and 36%, right? So I told the greater than 0, it means the strongly or positively or have a strong uh, relevance of R square, right? Okay. So in this way, we can investigate the predictive relevance. The last one is hypothesis testing. For hypothesis testing, we need to go back to bootstrapping and start calculation. Here you will see the path coefficient, right? This is the hypothesis testing. So these are the value of beta and mean standard deviation. Please see here the T statistics and P statistics, right? So these T statistics indicate that the relationship between internet addiction and the employee well-being is insignificant, right? On the other hand, the other two, I mean, social media use will have a significant impact on employees' well-being. On the other hand, social media use have a significant impact on the internet addiction, right? Okay, so this is the hypothesis testing. Okay, so we can just copy and paste in this way, or just how can I say, uh, render model image. Okay, we will export later in the copy to Excel workbook, right? And we can paste here. What is that? We can paste here actually. Okay, we can paste here, right? Oh my God, it's not. It's quite difficult to understand, right? Okay, time New Roman. Okay, and the 20, whatever 20. Okay, right now it's quite visible. Yes. So in this way, okay, I can make it more, for example, 30. Okay, so in this way we can investigate the hypothesis, right? So easily, actually, we can write in the right column here. We can create a column. This is, we can write here the insignificant, significant, significant, right? In this way we can test the hypothesis. Okay, so go back to the, yeah. So a quick remarks, actually. Evaluating the structural equation modeling is critical step in smart PLS analysis. Okay. So using the smart PLS 4 version, actually it provides a robust tool for assessing the model fit, path significant, predictive relevance, and many more. I mean, the yeah, impact, the effect size, right? Ensuring the validity of theoretical model. Okay, so in the next video, actually, I will describe for a long time. It will be a very long video, maybe 30 to 40 minutes or 45 minutes, right? So from first to last, actually, how you will report your, actually, we generated some findings, results, using the smart PLS 4. But when you present your report in your research paper or thesis or any other report, we cannot present in this way. Actually, there are some different lucrative and meaningful way, right? Okay, so in the next video, based on the published paper by the introducer of PLS SEM, Professor here, right? Uh, or Professor Ringel, I will try my best to present how effectively, efficiently, significantly, systematically, or scientifically you will present your report to your research paper or your thesis, right? So do practice at your home. Actually, PPLS SEM, and it's time to practice. Um, Up to the next video, actually, I do believe the next video will be the more valuable videos within the uh, uh, within the whole lectures, right? The next video. Okay, up to now, keep me in your prayers. Allah Hafiz. Bye bye.